Welcome my dear learners for this course on operations research. In this module 3 we were discussing on transportation problems. In our previous lecture we have discussed how to get basic feasible solution using northwest corner rule, least cost entry method or matrix method and Vogel's approximation or penalty method to obtain the basic feasible solution. Now moving ahead in today's lecture, let us discuss how to obtain the optimal solution from the obtained basic feasible solution. The basic feasible solution can be obtained by using any of the three techniques. Unless otherwise specified, always will use Vogel's approximation or penalty method, because penalty method will gives us almost the optimum solution itself because it accounts for least cost. Now let us solve a problem. First we will get the basic feasible solution, then we will check for optimality. The problem number 2 of our discussion on transportation problem states that a company has 3 production facilities S1, S2, S3 with production capacity of 7, 9 and 18 units per week of a product respectively. These units are to be shipped to 4 warehouses D1, D2, D3 and D4 with requirements 5, 8, 7 and 14 units per week respectively. The transportation cost in rupees per unit between factories to warehouses are given in the table 2. Determine the optimum allocation in order to minimize the total transportation cost using northwest corner method and stepping stone method. In our previous lecture itself, I have discussed we have 2 techniques to obtain the optimal solution for any transportation problem. One is stepping stone method, second one is modified distribution method or MODI method. Now he is clearly stating for basic feasible solution we should use northwest corner method, and for optimality test we should go for stepping stone method. Come, let us solve problem number 2. We have the table 2 representing the unit cost of transportation from the source to destination. Now if I move for solution of this problem, let me rewrite the table given. We have the warehouses D1, D2, D3 and D4. Always at the right will write the supply. Here supply is nothing but the capacity. Correct. And we have the production facilities S1, S2 and S3. Bottom always we write demand. Here demand is nothing but the requirement. Warehouse requirements. Demand is nothing but requirements. Correct. Now let us fill the table. Let me copy down the transportation cost. Since we are using northwest corner rule, let me write the transportation cost at the northwest corner of each cell. We have 19, 30, 50 and 10. Coming for the capacities, we have 7, 9 and 18 units. So here the unit cost are 70, 30, 40 and 60. We have 48, 70 and 20. Coming for demand, we have 5 units, 8 units, 7 and 14 units. Sorry, I skipped it here. I skipped a column. So it should be 5, 8, 7 and 14. That is, we should get one more column here. It is 5, 8, 7 and 14. Here we have demand, which is nothing but requirements. Requirements, which is given for us. Now first let us verify whether this is a balanced transportation problem or not. For balanced transportation problem, always the sum of supply should be equal to sum of demand. The sum of supply is giving 7 plus 9 plus 18, which is 34, It is giving the answer as 34. Coming for sum of demand, that is 5 plus 8 plus 7 plus 14, that is also 34. So since supply is equal to demand, this is a balanced transportation problem. Now in step 1, let us use northwest corner rule and determine the basic feasible solution. Now the first northwest corner is this one. Now for the first northwest corner, the demand is 5 whereas supply is 7, so therefore demand is minimum, so therefore I will put demand as 5, so therefore I don't have any allocation possible here, and this 7 will become 2, right? So the next northwest corner will be this one. So for this cell we have the demand as 8 and supply is 2 units, so therefore supply is minimum, so therefore I allocate the supply as 2 units here, so therefore this is not available for further allocation. Since I allocated 2 units here, so this will reduce to 6. Now the next northwest corner is this one. Here we have supply as 9 and demand as 6, minimum is 6, so therefore I will allocate 6 here, so this is not available for further allocation and this will reduce to 3, remaining is 3, right? So next northwest corner is this one. Supply is 3, demand is 7, supply is minimum, so therefore I will allocate 3 here, so this is ruled out from allocation. So since I allocated supply as 3, the remaining will be 4 plus 3 is 7. Now the next northwest corner is this one. Here we have supply as 18 and demand as 4, so 4 is minimum, so I'll allocate 4. Now remaining is 14, so remaining final allocation will be done here. So we have done the initial basic feasible allocation. Let us check how much is the cost and also rewrite the table. So the cost is turning out to be, the total cost from step 1 is turning out to be 5 into 19 plus 2 into 30 plus 6 into 30, then we have plus 3 into 40 plus we have 4 into 70 plus 14 into 20. So total cost will be rupees 5 into 19 plus 2 into 30 plus 6 into 30 plus 3 into 40 plus 4 into 70 plus 14 into 20, which gives us the initial basic solution as 1015 rupees, and the initial basic allocation is found to be for x11, x12, x22, x23 and x33 and x34 have got the allocation. Now if you look at the number of allocations as 1, 2, 3, 4, 5 and 6, the total number of allocation is 6. Total allocations is 6. We have made 6 allocations, 1, 2, 3, 4, 5 and 6, whereas number of rows plus number of column minus 1. So we have 3 rows plus we have 4 columns in the question minus 1, which is also 6. So since the total allocations what we have made and m plus n minus 1, that is number of rows in the cost matrix and the number of column in the unit cost matrix is 3 cross 4. So 3 plus 4 minus 1 is also 6. So number of allocations is equal to m plus n minus 1. Hence we have non-degenerate basic feasible solution. So this is the non-degenerate basic feasible solution obtained from northwest corner rule with 6 allocations, and the total transportation cost is found to be 1015 rupees. Now let us use this basic feasible solution, and by applying stepping stone method, let us improve the transportation cost. Our aim is to minimize the total transportation cost of transportation of these goods from production capacities to warehouses. Come, let us check for optimality by using stepping stone method. Let me pause this video for a while so that you people can copy it down. Later I will address stepping stone method. Now moving ahead to find the optimality test, that is step 2. Next, moving ahead for step 2, that is optimality test, we are using stepping stone method. Stepping stone method. Now in case of stepping stone method, we will allocate +1 units to the unallocated position and form a loop. Loop should be formed by going vertically downward or vertically upward, horizontally left or horizontal to right. You cannot go at any inclined lines. So if I allocate +1 here, and the loop should always connect the allocated cell. So I will allocate +1 to this unallocated cell. So next I can't go like this because there is no allocation. I will come here horizontally and then I will come down and then I will come here and I will connect. So this will form a loop, except at the unallocated position, and all the corners of the loop should be a allocated cell. If I go vertically downward here, I cannot come this way, I can only go this way, come back and come here. That is also correct. So let me solve this. So step 1, in step 2, in trial 1, you go for trial 1. So we have, let me write only the cost matrix and allocations. So we have 19, we have allocation as 5. Next we have 30, for which we have allocation of 2. Next we have 50, which is unallocated, and then we have 10, which is unallocated, right? So next, coming downward, we have 70, which is unallocated. Next we have 30, which is allocated with 6 units, and then we have 40 allocated with 3 units. Then we have 60 cost with unallocation. Next we have 40 as the cost, no allocation. 8, no allocation. Unit cost is 70, allocation is 4 units. And then we have 20, allocation is 14 units, right? So I rewritten only the cost matrix with allocations. Now for the unallocated cell, you give +1 units and form a loop. A loop should be always formed by using horizontal and vertical lines moving to the allocated cells. So therefore I'll go like this, I'll come down, again I'll come like this, and then I'll go up. This will form a loop. Clear? So since I have given +1 here, you give -1, give -1 here, that is you give minus, alternately plus and minus, you give alternately plus and minus, that is enough. Clear? Alternately you give plus and minus. Now because of this, the cost is +50, here I am using -30, here I am using +30, and here I am using -40. So calculate the penalty. What happens to the cost if allocation is given for x1, 2, 3? If allocation is given for x1, 3, so what is that I am going to get? Here I have +50, here a plus symbol, so calculate the cost. Here is minus symbol, it is -30. Next again we have +30, and here we have -40. So this yields us a net increase of 10, correct? So this gives us a net increase of +10. So therefore the allocation to this column is waste, to this cell is waste, because it further increases the cost, right? Plus 30 minus 30 will get cancelled, and 50 minus 40 is 10, correct? So this is ruled out. Next we will allocate here and see what happens. So next, if I go for allocating here and check in trial 2, if I go and check what I am going to get, 19, 5, next we have 30, 2, 50 and 10, right? Next we have 70, 30, allocation is 6 units. Let me write it in brackets to avoid confusion, or I am using sign in the brackets, so no need to worry. 2, 6, 40 is the unit cost, allocation is 3 units, 60 is the unit cost. Next we have 40 is the unit cost, here we have 8, then 70, we have allocation as 4, then we have 20, allocation as 14. So I written only the cost matrix with allocation, right? So since we have checked this one, next go for the unallocated cell, give +1, I'll go for x 1 4, now form a loop. So I can't go here because no allocation, so from here I'll go here, and then I'll go like this. So I should always go with allocations, keep that in mind. I'll go like this, and I'll come here, and then I'll go like this, and then I'll come here, and finally I'll come back. Clear? So you should always move to the allocated cells. So I come here, then I come here, then here, 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 and finally to the source. So here +1, alternately I should give plus and minus. Here is minus, here again plus, here is minus, here again plus. So +1, minus, plus, minus, plus, sorry, plus should come here, right? Plus and then minus. So now we calculate. We have +30, -20, +70, -40, +30 and -30. So if I go for allocating x14, so the net increase in decrease in cost will become +10. Then we have -20. So use the sign and calculate the cost. -20. Then we have plus here, +70. Then we have minus here, -40. Then we have plus 30. And then we have minus 30. Again we came back. So the net increase or decrease is found to be +10, -20, +70, -40, +30, -30. So we have a net increase of +20, which is not desirable, which is undesirable for us. So this is also ruled out. Next we have 4 more to check. Let us check those things. Moving for trial 3. If I move for trial 3, we have 19, 30, 50, and then we have 10 with allocations of 5 and 2 in x1 1 and x1 2. Next cost is 70, 30, 40 and 60, right? So next we have the allocations are 6 and 3 units. Unit cost are 40, 8, 70 and 20. Coming for the allocations, we have 4 and 14. So I checked with x13 and x14. Next move for x21. Give plus 1 unit here. If I give plus 1 unit here, I should form a loop. I'll go like this. I'll come here, come down and connect the loop. So we have found the loop easily. So since we have plus here, alternatively I should give minus, plus and minus, right? So if I go for x, x21, we have net increase or decrease in cost is to be plus 70 minus 19 plus 30 minus 30. So it is giving increase in cost as 70 minus 19, which is plus 51, which is not at all desirable. So all the three are giving increase in cost. So therefore next check for the unallocated position here, that is x24. If I go for x24, let me erase these things. Hope you have noted down. None of this is found to be desirable for us. So all the three possible possibilities that we have checked has been ruled out. Clear? Next we are left with checking x24, x31 and x32. Our aim is to find whether any of these cells will give us net decrease in cost. The first three what we have checked are giving that net increase in cost. So therefore these three are undesirable for us. So next moving ahead for trial 4. Now moving ahead for trial 4, again let me write the cost matrix. We have 19, 30, 50 and 10, right? Here we have 70, 30, 40 and 60, and finally we have 40, 8, 70 and 20, correct? And we have the allocations as here we have 5 units, 2 units, 6, 3, 4 and 14. So we already examined x13, x14 and x21. Now moving ahead for x24, give plus 1 units to this unallocated position and form a loop. So the loop will be like this. So from here I will start, I will come here, go down, so I will form a loop like this. Since we have plus here, this should become minus, this should become plus and this should become minus. Now calculate the net increase or decrease in cost by allocating to a cell x24. Here we have plus 60, the unit cost will be minus 20, and then we have plus 40 and minus 40, correct? Plus 60 minus 20 plus 70 and minus 40. 60, 20, 70 minus 40. So we have 60 minus 20 plus 70 minus 40. So this is also giving a net increase of plus 70, which is undesirable for us. So therefore trial 4 also failed. Move for check for this cell. So if I check for the unallocated cell x31 in trial 5, we have 19, then we have 30, then we have 50 and then we have 10. Our aim is to find out the net decrease in allocation. So all the 4 trials are giving us net increase in allocation. So therefore all 4 trials have become undesirable for us. Now let us check the remaining 2 which are waiting to be inspected, that is x3 cell number x31 and x32. So I noted down the unit cost. and coming for the allocations we have 4 and 14, right? So now I should inspect x31, so I'll give plus 1. Now there is a allocation here, so therefore I can go upward. From here I'll go like this, then I'll come here. Next allocation is only here. I can't come down because no allocation is possible, no allocation is present. So next I should, only option is I should go horizontally towards right side, come down and then connect. Clear? So I started from here, I moved up to the allocation. Next I came here, we have allocation. Next come down, move towards right, come down and then finally create a loop. So since we have plus here, here it should be minus, here it should be plus, here it should be minus, plus and minus. Now what is the net increase or decrease from x31? We have plus 40 as cost, minus 19, plus 30, minus 30, minus 30, plus 40, plus 40, then minus 70, minus 70. So this will yield us 40 minus 19 plus 30 minus 30 plus 40 minus 70. So we are getting minus 9. So there is a net decrease in cost as minus 9. So therefore trial 5 is desirable. Let us wait and finally let us check whether trial 6 also will inspect, and finally we will look for the allocation in trial 5. Clear? Let me finish checking all the cells, right? So now checking this one, moving ahead for trial 6. So inspecting for trial 6, we have we have 19, 30, 50, then we have 10, here we have 5 and 2 as the allocations. Next we have 70, 30, 40, 60, allocations are 6 and 3, and then we have the unit costs as 40, 8, 70 and 20. The allocations are 4 and 14, right? The only unexpected cell is here. You allocate plus 1 for x32. Now create a loop. So loop is very easy for this cell. I'll go like this, come here and then join. I'll found a loop. Since you have plus here, this should be minus, plus and minus. Now calculate the net increase or decrease in cost from x32. We have plus 8, then we have minus 30, plus 40, plus 40, minus 70. So we have 8 minus 30 plus 40 minus 70. So minus 52. So plus 8 minus 30 plus 40 minus 70. 8 minus 30 plus 40 minus 70. So this is also desirable. Now if you compare trial 5 and trial 6, trial 6 is more desirable compared to trial 5, because here the net decrease in cost is minus 9, here the net decrease in cost is minus 52. So therefore I should go for trial 6, which has the maximum decrease in cost, minus 52. So therefore up to this point you have understood, always you give allocation of plus 1 to unallocated cell, form a loop, alternatively write plus and minus, calculate the net increase or decrease in unit cost, and identify the minimum number among the cost what we have calculated, that is the most negative value. I found it as x32, that is minus 52. So therefore minus 52 is desirable. So trial 6 will give us the optimal solution. Now the optimal solution, to find the optimal solution, again you write the matrix once again, that is, now we have got the optimal, desirable optimal solution in trial 6, that is, we have the matrix like this. 19 is the unit cost, next we have 30, then we have 50 and 10, 70, 30, 40 and 60 as the unit cost, and finally we have 40, 8, 70 and 20 as the unit cost. Clear? And coming for the allocations, we have 5, 2, 6, 3, 4 and 14 units. Now from trial 6 we have found that if I place plus 1 unit here, it will become plus 8 minus 30 plus 40 minus 70, and we have found that there is a net decrease in minus 52. So since this is found to be desirable, now give the value as plus theta, hence this will become minus theta, here it will become plus theta, here it will become minus theta. Clear? Now what is the maximum value of theta that can be accompanied such a way that none of the allocations will become negative? Here theta can take up to 6, correct? Here theta can take up to 4. So therefore the value of theta such a way that the allocations will not become negative is theta can take only 4 units, right? If theta takes 4, this will become 0 and this will become plus 2 and this will become 7, right? It is the only possibility. So therefore whatever you have done in the step trial 6, where you have put plus 1 plus minus, there you substitute 1 by, replace 1 by theta. So plus theta minus theta plus theta minus theta, right? So now check for the allocations such a way that what is the value of theta that can be accompanied such a way that none of the allocations will become negative. The maximum value of theta that can be accompanied without making the allocations as negative is 4. So therefore give theta as 4. So if I give theta as 4, what I will get? If I give theta as 4, I will get the solution as, we have 19, then we have 30, then we have 50, then we have 10. So here we have allocations as 5 and 2. So next is 70, 30, 40 and 60 is the cost, transportation cost, unit cost of transportation, and next we have 40, 8, 70 and 20. Here the allocation is 14, right? Now I am giving the value of theta as 4. So here we have allocations will become 4 here. So this will become 2 and this will become 7, right? So allocate the value of theta as 4 such a way that these 3 will not become negative. This will become 0. Here I will get 4. 6 minus 4 is 2. 3 plus 4 is 7, right? So now you calculate the total cost. So now if I calculate the total cost, total cost is found to be 19 into 5 plus 30 into 2 plus 30 into 2 plus 40 into 7 plus 8 into 4 plus 20 into 14. So this yields us the total transportation cost will become 19 into 5 plus 30 into 4 plus 40 into 7 plus 8 into 4 plus 20 into 14, which become 721. So you can see that the initial basics feasible solution gave the total cost as 1015 rupees. Now it has reduced to 721 rupees. Is this the optimum solution? We don't know, right? So further we should inspect whether this is optimum solution or not by again testing the stepping stone method, such a way that all the values of the net cost should be positive values. We should not get any negative values. Then the solution will become optimum. So to do that, let me test it here itself. If I go for allocation to x, further if I go for allocation to x31, so if I go for allocation to x31, I will create a loop like this. Here I will create a loop like this. I will give plus 1, I will come down minus, plus, minus, again the loop. So therefore the net increase or decrease will become how much? Plus 50, minus 40, minus 40, plus 30, minus 30. So there is a next increase of plus 10, right? So 50 plus 50 minus 40, minus 40 plus 30, minus 30, there is a net increase of plus 10. Now if I check for this one again, so I will get x32 as, here I have plus, right? So from here I should create a loop. I will come directly here, and then I will come here, and then here, and then here. Clear? So this will be my loop. So therefore it will be plus 10 minus 20, plus 10 minus 20, plus 8 minus 30, plus 8 minus 30. That will yields us the result as 10 minus 20 plus 8 minus 30. So that is minus 32, plus 10 minus 20 plus 8 minus 30, minus 32. We got one more negative. Next, inspect this one. If I inspect this one, that is x, sorry, 1 3, sorry, these are x first row third column, this is first row fourth column. Next, coming for second row first one, second row first cell. So if I allocate plus 1 here, so this will be the loop. So this will become 70 minus 19 plus 30 and minus 30. So this will yield us 70 minus 19 plus 30 minus 30, that is plus 51. Next, if I go and allocate here and create a loop, so I'll come down, come here, move up and join. So this will be the loop. Clear? So if this will be the loop, then we have x24 will become plus 60 minus 20. Then I'll come here, that will be plus 8, I'll move up minus 30. That is plus 60 minus 20 plus 8 minus 30. This is plus 18. We have two more, that is x31. So if I go for x31, that will be, now the loop will be like this. I'll create a loop. So therefore plus 40 minus 19, plus 40 minus 19, plus 30 minus 8, plus 30 minus 8. So 40 minus 19 plus 30 minus 8, it will become plus 43, which is also undesirable. Now moving for the last one, if I put plus 1 here, the loop will be like this, or it will be like this. So this will be my loop, that is x33 will yield us 70 minus 8 plus 30 minus 40, 70 minus 8 plus 30 minus 40, that is 70 minus 8 plus 30 minus 40 will be 52, plus 52. So therefore if we inspect all four, again we got x14 is found to give us further decrease in the transportation cost. Therefore I should go for allocating to x14. We have x14 here. right? x14, I created a loop like this, 10 minus 20 plus 8 minus 30, 10 minus 20 plus 8 minus 30, 10 minus 20 plus 8 minus 30, minus 32 units. So therefore this is desirable, right? So this is desirable, so therefore I should go for this one again in next trial. So go for trial number 7, such that in trial number 7 I should give theta to this one. Instead of plus 1 I should replace it by plus theta and find out such a way that what is the maximum value of theta that can accompany, such a way that the loop which I created will not cause any negative allocations, right? So next, the further improvement is appearing to be obtained. So therefore let us go for trial number 7. That is, in trial number 7, now moving ahead for trial 7, we have 19. So in trial 6 we found that the optimum total cost is found to be 721 rupees, for which the allocation was found to be in trial 6, which you have noted down. And when we again tested for optimality, we found that there is a further improvement if we go for allocating to x14. So until you get all the values of cost that you have calculated by using stepping stone technique to be positive, we should keep repeating this thing. So we have 40, 8, 70 and 20. The allocations are 5, 2. So now here we have found the optimality with 721 rupees as, here we have given it as 4. So this has become 2, correct, and this has become 7, right? This is what we had in step 6, trial 6, and found that optimal cost for this is 721 rupees. And we again tested for optimality, we found that using x14 the total cost is further reducing. So therefore I'll give this as plus theta, and the loop is created like this, minus theta. I come over here, plus theta, I came over here, minus theta, and connected the loop, right? Now what is the value of theta such that the allocated cells will not become negative? That is, theta can accompany only 2, correct? So further increase will cause the allocated cells as negative values. So therefore maximum value of theta that I can give as 2. If I give 2, this will become 0. So therefore the optimum allocation in trial 7 is found to be 19. Here we have 5 units, next is 30. Here it will become 0 because I am allocating theta as 2, 50. So here 10, we are allocating it as with 2 units. Clear? So next we have 70, 30, 2, 40, we have 7, then we have 60. Next coming over here, we have 40, 8, 70 and 20 as the unit cost. And coming for allocations, 14 minus 2 is 12, 4 plus 2 is 6. Done, right? So we are telling that this is the optimal solution. Again we should inspect whether there is a net increase or decrease by inspecting unallocated cells by creating a loop. Before that, let me calculate how much is the total cost. So the total cost will be, total cost will be 19 into 5 plus 10 into 2 plus 30 into 2 plus 40 into 7 plus 6 into 8, that is 8 into 6 plus 20 into 12. How much is the total cost now? Is it less than 721? Let me check. 19 into 5 plus 10 into 2 plus 30 into 2 plus 40 into 7 plus 8 into 6 plus 20 into 12. We are getting it as 743. How come 743? I think I have made a calculation mistake. Let me recalculate once again. 19 into 5 plus 2 into 10 plus 2 into 30 plus 7 into 40 plus 8 into 6 plus 20 into 12. 743 is correct. I think the trial 6 calculation might be wrong. It is not 721. Let me recalculate once again. Here in trial 6, what was the total cost? In trial 6, the total cost is 19 into 5 plus 30 into 2 plus 30 into 2 plus 40 into 7 plus 8 into 4 plus 20 into 14. So here in trial 6 it was found to be 19 into 5 plus 30 into 2 plus 30 into 2 plus 40 into 7 plus 8 into 4 plus 20 into 14. Sorry, we have done a calculation mistake. The total cost is 807 rupees, not 721. It is 807 rupees. Kindly correct it. So therefore, in trial 7 we have found an improvement, right? So in trial 7 we have found an improvement. Now again you check whether this is optimal solution or not. So if I give plus 1 here, then the loop will be like this, correct? So this will be the loop. Only possible loop is this one. From here I will go to 8, 20, 10 and come back. So therefore again check for optimality. Else you should go for trial 8. So if I give plus 1, that is x12 will gives us plus 30 minus 8 plus 20 minus 10, which is 30 minus 8 plus 20 minus 10 plus 32, positive, which is not desirable. Next go for this one, that is x13. If I go for x13, how do I form loop? I can form loop as, from here I should form a loop. If I come here I can't come down. If I come here, then here, right? So the loop will be like this. From here you come down, move to allocated cell, move to allocated cell, move to allocated cell, move to allocated cell, move to allocated cell. So that is plus 50. I'll come down minus 40. Then I'll come here plus 30. Then I'll come down minus 8. Then I'll go here plus 20. Then I'll move up minus 10. It will be 50 minus 40 plus 30 minus 8 plus 20 minus 10. 42 plus 42. Next is here. So go for x21. If I go for x21, I should form a loop. The loop will be again, so from here I'll go up, then I'll come here, come down, come here, move up and connect. So the loop will be like this. Move to 20, 8, 30 and 70. So therefore we have 70 minus 19, 70 minus 19 plus 10 plus 10. From there I came to minus 20, minus 20 plus 8 and minus 30. It will be 70 minus 19 plus 10 minus 20 plus 8 minus 30. it is plus 19. Next check for this one, that is x24. If I check for x24, the loop will be, will come down, come here, this one. So this will be the loop 60, 20, 8, 30, 60. That is 60 minus 20, 60 minus 20 plus 8 minus 30, plus 8 minus 30. It is 60 minus 20 plus 8 minus 30 plus 18. This is also positive, which is undesirable for us. Next we have x31. If I check for x31, from here I should form a loop. The loop will be, so from here we should form a loop. How do I form a loop? Yes, all the four corners is the loop. From here 20, 10, 19 connect, right? So it is 40 minus 20 plus 10 minus 19. 40 plus 20 minus 20 plus 10 minus 19. 40 minus 20 plus 10 minus 19 plus 11, which is positive. So finally we have x33. If I check for x33, form a loop. So this is the loop, that is 70 minus 40, 70 minus 40 plus 30 minus 8, plus 30 minus 8, 70 minus 40 plus 30 minus 8 plus 52. So if you carefully observe, all the values are positive, hence the problem terminates. So this is the optimal allocation and this is the optimal cost for the given problem. So since all the values of the unallocated cell costs are found to be positive, the problem terminates and this is the optimal solution. So this is the optimum allocation. So this is the optimum allocation and this is the optimum cost. So the optimum cost is found to be rupees 743 and this is the optimum allocation and this is the solution for problem number 2 by using stepping stone method. So this is the optimum allocation and optimum cost and it is found to be rupees 743. In step 6 we found it as wrongly calculated as 721. It is not 721, it is 807. Kindly correct it. The correct solution we have obtained, the optimum allocation also found, the optimum cost is also found. If any one of these is found to be decreasing the net cost, then again you should repeat the same procedure. You should repeat and repeat until you get all the possible unallocated positions have positive costs. Then the problem terminates and we obtain optimum allocation and optimum cost. The optimum cost for this problem, the basic feasible total cost is found to be rupees 1015 from northwest corner rule and the optimum cost is found to be rupees 743 from stepping stone method. So this is the solution for problem number 2. That's all from this lecture. Thank you all.